Okay, so the body uses feedback, producing changes in response to changes to react to its environment. It uses positive feedback to drive processes to completion. It uses negative feedback to maintain homeostasis, which is its internal balance or equilibrium. Well, the real question now is how does the body use feedback? What's the mechanism by which it uses feedback? To make this a bit easier to think about, let's start with something that's not the human body. Let's start by thinking about a house. I want you to imagine a house on a warm summer's day. A warm summer's day in which radiation from the sun is heating up the atmosphere, and in which the atmosphere heating up is transferring its heat into the house and causing the air within the house to increase in temperature. We have here a very simple example of an external environmental change, a warmer atmosphere outside the house, causing an internal change, a warmer atmosphere inside the house. And the question then is, what do we need to maintain constant temperature within the house? Literally, I'm not asking this in a figurative sense. I'm saying physically, what do we have to have? Well, let's think about this. We have to have a way of measuring air temperature in the house. If we can't detect what temperature is, we can't determine that it's changing. And if we don't know that it's changing, we can't respond to that change. We also have to have something to produce the feedback, right? We have to have an effector of some kind, an object or a machine, to change the air temperature. And finally, we have to have some sort of decision maker who determines when the temperature has changed enough to justify activating the device that changes temperature. So to stop talking about this in the abstract, let's put some actual structures to this. We need a thermometer somewhere in the house, a device that measures changes in temperature, which will be the receptor. It will detect change in temperature. We need an air conditioner. We need a device capable of changing temperature in the house, a device that can have an effect on temperature or an effector. And then finally, we need something that can determine and maintain the set point. We need a decision maker as a go-between, a thermostat. And that thermostat is our control or integration center. And so the way this works is temperature outside rises, so temperature inside rises. That increase in air temperature is detected by the receptor, the thermometer, which communicates with the thermostat, the control center, which realizes temperature has now exceeded set point by a good bit. It then communicates with the effector, the air conditioner, which turns on, lowering temperature in the house, and there is our feedback. Now notice as I've drawn this, we have this lovely little circular diagram on the page. We have what's called a feedback loop, a collection of structures or a single structure that produces feedback in response to an environmental change. And these feedback loops have to have three parts, as we just saw: a receptor, a control center, and an effector. So to define those terms a little more formally, the receptor is the cell or organ in the human body. Now we're moving away from the house. It's a cell or organ that detects changes in a particular physiological variable. And when you're encountering real feedback loops within the human body, you can recognize the receptor as a structure that detects a change, is sensitive to a change, or in a lot of cases, it's the structure whose name has the word receptor in it. Now, you can't rely on that all the time, but a very large number of the body's receptors do have the word receptor in their name, so don't overlook that. The control center is the decision maker in the feedback loop. It's the cell or organ that decides when to act in response to the change. And you're going to recognize control centers sometimes because they're obviously behaving in a way that indicates they're a decision maker. You can expect many but not all control centers to be in the central nervous system. A lot of times you recognize it most easily by realizing it's the structure that is in communication with both the receptor and the effector. And the effector, again, is the cell or organ that produces the effect that changes the physiological variable at the output of the system. It's always a muscle or a gland. And so the effector will be recognized because it's smooth muscle tissue, cardiac muscle tissue, skeletal muscle tissue. It's a gland of some kind. And most importantly, the action of that organ leads to a change in the physiological variable that changed at the beginning of all of this. So those are the parts of the feedback loop. What I'm going to do in the last video that's coming up next is diagram out a feedback loop for you in the human body
and talk through a couple of actual examples to illustrate how all of these pieces get put together.